Hello everyone, my name is Sharat Devadiga and I belong to Cohort Resolution. As a part of DSA project, I will be explaining for you coding problems. So this is the broader roadmap. So what I will be doing is first I will explain the problem statement, and then I will explain the logic, and then I will address the corresponding demand of the question. So in the project documentation there were actually 5 different sections, each having the different demands. First was about the code bug fixing section, where the one code was given and we have to find and fix the bugs. There I have chosen the height based sorting problem. Then in the second section it was basically about giving an alternate and improved solution for the given problem. There I have chosen a palindrome number problem. And in the third section we have to give the entire logic by ourselves based on the problem statement. Here I have incorporated the transition point problem, where we have to find the transition of the binary array from 0 to 1. And in the fourth section it was basically an analysis section. We have to analyze the traditional and optimized approach for the given problem. And the last section was incorporating both best and the worst case coding solution for the given problem. Here I have incorporated the flip image problem. So let's directly jump into the first section. It was the code bug fixing section. Actually there were two arrays given, one with the names of some persons and another with the heights. So the problem statement states that we have to sort the array of names in decreasing order based on their corresponding heights. So this is the logic of the given problem. So what we can do is we can use the heights as the keys and the names as the values in a map, and we can construct the map by just using all the heights and all the values. After mapping all the values, we have to sort the given heights array, and after sorting that we can revisit each heights of the individual person and look for the corresponding key in the map, and then we can construct the sorted names list, and finally we can return that. The time complexity of this logic is going to be O of n log n, and space complexity is going to be O of n, because here we have used the sorting algorithm, and in the space we have used the map data structure. This was the given code. First they have determined found the length using heights.length, and declared the map data structure, iterated through an entire array, and constructed the map data set, finally sorted the given height and declared a result array, finally revisited the heights which is already sorted, and got the corresponding name from that mapped values and returned the result. So the main problem or the bugs over here is that in the length property they have used the flower and the brackets. There is no need to use the brackets, and while iterating through the array they have to just start from the 0 and until n minus 1, where n is going to be the length. If the iterating pointer reaches beyond the last element, it is going to give the index out of bound error. Same thing is going to happen in this case as well. By fixing these two bugs we can make sure that the code works correctly, and this is the corrected code. Entire section is almost same, but we have fixed the bugs in these two regions. So moving to the next section, it was about improvised perspective section. So the problem is the palindromic number. So if the number was given like this, we have to find whether the given number is a palindrome or not. So the entire idea is pretty much simple. We have to see the last and the first elements respectively, and we have to repeat the same process towards the middle of the array. If all those elements are corresponding elements are equal, then we gonna say that the given number is the palindrome, otherwise it's not gonna be a palindrome. So this is the second problem from the section 2 of the given project documentation. So let's discuss about the given approach. They had used an approach where the duplicate of the entire number is reconstructed by iterating through the entire number, and not exactly iterating but reconstructing the duplicate number by extracting the remainder element from the given number. This can be easily done by modding the given number with 10, and finally we can construct the duplicate number step by step by adding the remainder to the our duplicate number, which is multiplied by 10, and finally we have to strike out the remainder in that corresponding iteration. We can do that by dividing the given number with the 10, and finally we have to just check whether the given number and the reconstructed number in reverse is equal or not. If both are equal, then we are gonna say the given number is a palindrome and simply return true, or otherwise we have to return false. But the main issue over here is that suppose if the number is very large, then we have to reconstruct the entire number, and then only we can say that the given number is palindrome or not. But there will be lot of unnecessary computations or unnecessary steps we are gonna take in this method. So the better approach is by using the two pointer approach, so where we are gonna say that if the last numbers are equal, then only we can compare the next elements. So if they are not equal, then we immediately we are gonna say that the given number is not a palindromic number. So how we can do this is simply by using the two pointers. Let's say I and j, we gonna set those two pointers to the first and the last position respectively, and we have to check whether they are equal or not. If they are equal, then again we have to check the next successive elements, and we have to repeat the process until I and j reaches the middle element. This is what we have done in this code. Yeah. And it's having the time complexity of O of d, where d is the number of digits in the given number, and space complexity is O of 1 because we are not using the extra space. So yeah, this is all about this problem. Moving to the next section, which is the logic building section. I have chosen the fifth problem from that section, which is the transition point problem. There was some binary array which is like this: 0 0 0 and 1 1. Let's take this as our example. We have to find where exactly the transition took place from 0 to 1 in the given array, and we have to return that index accordingly. So this was the basic problem statement. Then moving to the logic. So since we have to find the transition point, I thought of just brute forcing and checking whether every position is 1 or not. If the current element is 1, then we are gonna say that the current position is the transition point. But there is a better approach, and that is by using the binary search. So the binary search, what we have to do is we have to use the two pointers, left and right. We are gonna set left to 0 and right to length -1. So here you can see we have done the same, and we have to calculate the mid by using the formula L plus R by 2, and we have to check whether our middle element is 1 or not. If it is so, then we have to store the middle position as our result, and one important point we have to notice: we have to not just find 1, but we have to find the first occurrence of the 1. So we have to shift shift the right pointer to the left of the middle elements, just to ensure that there is just to check whether there is the occurrence of 1 behind that middle element. If so, then we have to search for that, and then we have to make sure that we are returning the correct position. So yeah, this is it. And suppose if the array at suppose if the element at the middle position is less than 1, then we have to update our left pointer to the right, and we have to check in the next section. So this is the most optimized approach, and it's having the time complexity of log n, because in the each iteration we are cutting the size of array by n by 2, and we have to look only in the next section only. Yeah, and the space complexity is going to be of 1, because we are not actually using any extra space for this problem. So going to the next section, it is about analyzing the traditional and the optimized approach. For the given problem, both the traditional and optimized approach were given. We have to just analyze those approaches in the form of time, space, and the execution speed. So the problem statement was pretty much simple. If this was the given array, we have to find the two numbers which are going to add up to the given target. So the first approach was given as the brute force approach, where they have iterated through the array once and successively iterated through the array from from the next element of the I, and comparing each element with the first pointer, and finding the sum of array of I and array of j, and checking whether it is equal to the target. If they are so, then returning the array of I and array of j. So it's gonna have the time complexity of O of n square, and space complexity is going to be of O of 1, since there is no extra data structure used, and the execution speed is definitely going to be slower. And coming to the optimized approach, here instead of using the brute force, we can make use of the hash map or an object, just to store the values. So what we can do is we can start iterating the given array from 0 till the end of the array, and we have to calculate the difference by subtracting the current element from the target element, and we have to check for that difference in our hash map. If we find the corresponding difference, and then we can definitely return the current element and the difference as our result. So this is what we have done here. So since there is only one for loop and one data structure, we can definitely say that the time complexity is going to be of n, and space complexity is also going to be of n, and the execution is going to be much better and speedier than the traditional approach. So this is what we have discussed so far regarding the problem. So moving on to the final problem, incorporating both the best and worst case scenario of the given code. So this is a quite interesting problem, and personally I felt very much excited about this problem. So this problem gives an image in the form of the matrix consisting of the zeros and ones. This was not actually given in the documentation. I just have included it to visualize the problem in a much better and understand it in an easier way. So if this was the given matrix, we can represent it like this: zeros representing the white space and 1 is representing the black space. So the problem states that we have to flip the given image first by reversing the given image, and then by inverting, just to enhance its visual contrast. On reversing, we can see that the structure like J is going to reverse like this, and on inverting, the zeros are going to replace with 1 and 1s are going to replace with zeros. So how we can do that? So the worst case is by using the brute force, that is visiting every row once and reversing that row, and finally inverting the corresponding elements. So what we have done here is visiting the row, it's gonna take up the time complexity of n, and again reversing that corresponding row, it will be taking time complexity of n, and visiting each and every element once. So overall the time complexity is going to be O of n into n plus m, where n is number of rows and m is number of columns. So here the outer pointer I will take us to the each row, and then we are reversing every row one after the other, and finally we are replacing every row element with its negation, that is by replacing 0 with 1 and 1 with 0. Definitely it's not the optimized approach. So coming to the best case, instead of inverting the rows and then replacing zeros with 1 and ones with 0, what we could have done is we could simultaneously done both of them in the one go, or in other words in one pass. We can just do the both steps simultaneously. So as you can see here, I have iterated through the row only once, and then I have used the two pointers to swap the elements, and simultaneously I am replacing 1 with 0 and zeros with 1 using the not operator. So its time complexity is going to be O of n into m, where n is the number of rows and m is the number of columns, and the space complexity is going to be O of 1, since we are not using any external data structure to store the values. So finally recapping, first we have discussed about the problem where we have to find the bugs and fix it. It was about height based sorting problem, and second was about using the two pointer approach to determine whether the given number is a palindrome or not. Finally, the third section was about the transition point. We have to find the transition point and return its corresponding index. And the fourth section was about the analyzing section, where we have to find the two numbers which are going to add up to the given target number, and the main focus point of this problem was to analyze the traditional and optimized solution of the given problem. Finally, we have discussed about the flipping image, first by reversing it and by inverting it. Yeah, that's it for this project. Thank you.